I want to thank all of you for coming here today. My name is Julian Dawkins, and my company is Dawkins Golf. First, talking a little bit about myself. I will be going to the University of Wyoming next year in the fall for petroleum engineering in the Honors College. A little bit about my engineering background. I've taken 4 years of technology classes at Grandview, consisting of technology drawing, architectural design, technology education 1 and 2, as well as this year's senior projects. Moving into my golfing background, I played for Grandview on the varsity team for 2 years and the JV team for 2 years as well. And I've been playing competitive golf for 5 years, but overall my golfing career has extended well beyond that. A little bit about my project inspiration. I'm a golf junkie. I like technology. Golfers spend thousands of dollars on clubs for oftentimes no real apparent reason, and we're always looking for that extra little bit of technology to push us beyond to the next level. So I saw technology progressing through in the golfing world with drivers and metal and fairway woods. In the last 15 years with graphite shafts, in more recent years with adjustable weight tracks. And I decided that I would implement this idea of a weight track into a putter, which hadn't been done before. So this is the weight track that I'm talking about right here. There's a sliding weight that can move all across the club, moving the center of gravity. Same thing is present on my club right here. It can move from the toe to the heel of the putter, which moves the center of gravity back and forth. A little bit about my project as a description. The goal of this is to create a game improvement club. I wanted to create something that would benefit the player, and I think I was pretty successful in creating an effective weight track. I wanted to take a concept that had been used outside of putters with drivers, as shown, and implement it into something that hadn't been used before. And then I also wanted to test this weight track in real life, and the goal was to test it quantitatively, and I ended up mostly testing it qualitatively. At the beginning of the year, we developed 5 project objectives, which were to learn about the manufacturing process of machining metal. I hadn't done machining metal before in CNC manufacturing. I'd only done 3D printing, and so that was one of my goals, was to learn how that works, what steps need to be taken in order to produce something that has been manufactured from a CNC machine. I also wanted to gain a better understanding of SolidWorks. I had done a little bit of SolidWorks in the past, taking my CSWA, but I wanted to move forward and take my CSWP, which unfortunately I ran out of time for, and hopefully will be taking and moving forward. I also wanted to understand if this is a career path for me. I wanted to look at what the people in the golfing industry were doing, what their day-to-day activities looked like, and how this could translate into a possible career for myself as well. I wanted to meet with people in the industry. One of those people was Dan from Carbon Putters. He was one of my advisors, and he was the person that started this company. Started out in his basement. He bought a CNC mill, and then from there taught himself SolidWorks. He was already a golfer and taught himself how to make custom putters. Moving forward into my company logo, my friend Jake Shahet, who has a background in graphic design and art, assisted me in developing the logo. We wanted to keep a gray scale in order to kind of invoke a sense of status. In the golfing industry, people buy clubs for a status symbol. Like I said, people spend thousands of dollars. There are these clubs called PXG, and you can buy a set for over $10,000. So when you're spending the same amount of money as you could on a car, you have to kind of imagine that that's a status symbol for some people. And in that way, I wanted to also see my logo as a status symbol. We also implemented the putter, as well as the G and the D into the logo. Moving forward into my project timeline, my initial thought was that I was going to jump right into design in manufacturing, and a lot of that didn't actually end up happening. I ended up having to do a lot more research than I initially thought of to begin. And so that took up a lot of my first semester. It was a lot of research about club constraints and other pieces. Towards the end of the first semester, I began to do more design in SolidWorks. I created my first iteration of my putter head design, which I then 3D printed at the end of January. From there, I realized that I had a lot of work that I needed to do, that this wasn't going to work if I CNC manufactured it. And from there, I moved into more iterations and ended up developing this design, which had a different sight line. I had a different face milling pattern on the front, as well as a few other features such as a strengthened neck attachment for where the shaft attaches to the golf club. Towards the end of March, my plan was to take my CSWP. Unfortunately, I ran out of time. I had a lot more design issues than I had initially anticipated. From the beginning of the year, I said I was just going to start design, and then I had to create multiple designs that I didn't really account for, and then there were some backwards compatibility issues that I had with SolidWorks and the manufacturing process, as well as having to create multiple CNC pieces. This was the first one that I had initially anticipated of creating, and we messed up the Z depth, and so there's not enough room on the back, and so we had to restart this. So this was a waste of a block of carbon steel and about 8 hours. Also, in my initial timeline, I had suggested that one of my main goals was to research into obtaining a patent. I had thought that that would be a viable option. Upon doing more research and talking with my advisor about this, I found that patents are extremely expensive, often well over $10,000, and that if this was going to be a step moving forward, I would probably need more time for data and other research components to prove that this is a unique design, as well as that is an effective one as well. So a little bit into my research on my club constraints. One of the first pieces was the lie angle of the putter, which is the angle between the shaft and the ground. So this angle, the USGA, or the United States Golf Association, dictates that it cannot be more than 80 degrees. This was not going to be an issue for me, as according to my height, my stance, and other things like that, I was going to use 71 degrees. In addition, shaft lengths can only range from 18 to 48 inches. This was not going to be an issue either, as a pretty standard putter length is 34 inches, which is what I also chose. Another thing is the loft angle. Most people don't realize that a putter does have loft on the club face. As you can see here, the loft ranges from the vertical to the club face, and that is actually a cut across. Putters have to have a certain amount of loft, more than 2 degrees, and so pretty much the industry standard is 4 degrees, which is what I also chose. I also had to do some research into the golfing rules, which were some weighting restrictions as well as face milling restrictions. In the weighting process, the slide that goes across here cannot be readily adjusted throughout the round. So if you're playing a round of golf, you have to put it into a position and keep it there for the entire 18-hole round, which takes about 5 hours. So as you can imagine, you want it pretty secure. That is why most golf clubs that already have adjustable weight tracks use a wrench like this that has a torque spec on it. And I decided to implement a similar style bolt into mine so that you can tighten it down and not worry about it. I also wanted to implement a face milling pattern into my putter. There are some restrictions involved with this about the depth and the separation of the lines that go across the face. Here are a few examples of different face milling patterns, as well as a weight track. I also did some research into materials. I had a couple options for materials for one-piece CNC manufacturing, which were stainless steel 503 and stainless steel 504, as well as carbon steel 1025 and carbon steel 1018. I ended up choosing carbon steel 1018 cold rolled bar, as that is what would work best for my putter. The blocks of stainless steel that carbon putters had were all much too large or much too small, sorry. And the only option that I had, unless changing my design, was to use carbon steel. Another thing with carbon steel is that it's a preference for a lot of golfers. They say that it provides better feel off the face. And another thing with carbon rather than stainless steel is that it rusts in patinas, which a lot of people like and some people don't like. So if moving forward I didn't like the rust that was going to appear in it, I could get a finish over it, or if I liked the rust, I could stick with that. I also had to do some research into how I was going to create the weighting system. Initially, what I thought I was going to do was 3D print the whole thing from a Mark Forged 3D printer out of carbon fiber, and then from there, take the weight, create a hollow design, and fill it with tungsten shavings to achieve my desired weight goal. I found out that this wasn't going to be a very strong option, as the weighting track was so small that it would be better to purchase a metal bolt as well as a metal nut to fasten in the bottom, so that they would already be made out of metal and I wouldn't have to insert them with tungsten shavings or another material. I also did some research into some testing systems. Initially, I had wanted to do a lot of data testing on my putter, and one of the options with this would be the Quintic putter system. This is a high-speed camera system where you make 6 strokes with a golf ball, and then it pops out a sheet of data like this. So you get a bunch of different things, including impact club speed, shaft angle, what your degree of path was, what your face angle was at impact, and a few other things. And I figured the face angle would be the most important on this if the weight track was going to make any difference. And unfortunately, this was not an option for me. These are very expensive systems, and I didn't have the resources in order to continue testing. But moving forward, I would like to find one of these to test with and reach out to some people regarding that. I also did some research into moment of inertia with putters. One of the aspects of putting is that there is more weight towards the toe and the heel, and then a cavity in the middle. This means that there's more mass on either side and less in the middle. And what this does is it increases the velocity of the ball coming off of off-centered strike. So if you were to hit it out of the toe or the heel, you would achieve the most desirable amount of ball speed off of that, which creates a straighter ball path as seen here. So that was going to be one of the things. If I was going to increase the thickness of my putter, I was going to have to recognize that that would change moment of inertia and what that would do for the putter and the golf. A few things with the design. I encountered a few issues with creating the SolidWorks file for this putter. Like I said, my initial design was flawed in many ways. It wasn't large enough. The face milling pattern was too fine. The weight track was too small. There wasn't enough support on the neck attachment. So I needed to go back and make a few adjustments. And after about 3 reiterations of that design, I came up with this one, where I strengthened the neck, I changed the top line, I thickened it quite a bit, and I changed the face milling pattern. In the end, I ended up choosing a face milling pattern between these two, one that was deeper and wider than the one seen here in my first design, but that was finer than the one in my second 3D printed design. Here are a few of my SolidWorks drawings. This was the first putter design that I created. As you can see, the weight track is very small. One of the things in SolidWorks is that when you make it on a computer, you picture it being a lot larger than it really is. So you see it on the computer and you think, oh yeah, that's big enough. and then you 3D print it in real life, and there's nothing there. Here is the first iteration of the weight track that I designed. You can definitely see the struggles that I encountered with it being too small. I made the weight just over ½ an inch. And on the computer that looked fine, and then I 3D printed it and realized that if I was going to have a screw that was 1/8 of an inch in diameter, that I couldn't have threads on it. So I redesigned my weighting track system with a much bigger screw this time, with larger threads that would be more easily machinable, as well as a different weight track and a different weight. Now I ended up not using these screws and weights as seen because I wasn't able to achieve the desired amount of weight in the putter in the sliding track with that. Okay. So I had a video of the manufacturing process. Okay, so I had a video of the manufacturing process that I did at Carbon Putters. One of those things, they use a bunch of CNC machines there. They have about 5 industry-grade CNC machines that take up an entire warehouse suite. And one of the things with these CNC machines is that they have to use a solution to keep the bit cooled, and from there, that is what I made my putter out of. This is what it looks like in the first roughing stage. And that was what was shown there. And these jaws are used to clamp down the putter and hold it in place, and from there, the bit has less chattering and is able to cut the steel off and take it from a solid block into one piece of a putter. I also had a video of testing. So I went out on the course and I played 18 holes. And I noticed a few things about the putter. I noticed that I really liked the weight of it. It was a little heavier than my previous putter, which I really liked. I really liked the feel off the face. And another thing was I could notice when I moved the weight around the shift in center of gravity. That was a pretty important thing for me because I was mostly doing qualitative data or qualitative analysis, and because of being able to notice it, I could tell that my design had done something. I also had a few of my golfing colleagues test it out. Matthew Conger hit some putts with it around the course, and he really liked the look of it. He noted that it was up to industry standard, and he said that he really didn't think that the weight track hindered the look of it or the overall performance, and that it actually helped. Another thing with the weight track was that because I could feel the weight moving around, that gave me the impression that it was actually doing something. And some of this might have been a little bit of a placebo effect, where in sports, if you believe that the technology is helping you play better, then it actually is. So if I'm purchasing a golf club with this technology and it says you're going to hit putts straighter, then I'll probably hit putts straighter because I believe that it's helping. Continuing with the testing, I thought that the putter was really visually appealing. I really liked the look of it. I didn't think that me manufacturing it was a hindrance to the overall style of the putter. I thought it performed really well. I was really surprised. And I really liked how, because it was a custom putter, all pieces of it fit my stance and stroke. I liked it better than my previous putter as well. Moving into my advisory committee, I would really like to thank Dan from Carbon Putters, who is not here today. As I had previously stated, he was the one who started Carbon Putters, and began their manufacturing and design of custom one-piece CNC mill putters. They won a few awards from My Golf Spy and Golf Digest for having Best Blade of the Year. Also moving on, my expert advisor was Raymond Pointer. Unfortunately, he lives in North Carolina, so he was not able to be here today. But he worked with Vokey Wedge's Titleist and Scotty Cameron for a number of years as one of the lead designers for them, obtaining over 30 patents for them in the areas of wedges, putters, and drivers and graphite shafts. I thought he would be a really big help into design and keeping with industry standard, and he really was. I would also like to thank my parents. Without them, this wouldn't have happened. They provided financial assistance. One of the things with golf is that it's really expensive. Dan from Carbon Putters was really kind to me, and he only had me pay for materials, which was about $230. But they said that if they were to produce this putter on an industry level, it would be about a $600 to $700 putter. So thank you to my parents for financial support. Also, both of them are golfers, so they understood what my project was doing and how it was going to progress to the next level. I would also like to thank some of my classmates, Chase Gordonier, Daniel Rivkin, and Jack Rogers for the support that they had in this project, as well as Steve Smith. He was a teacher over at Eagle Crest in a similar research-based project class, and he was a big help in developing all my final deliverables for today. Thank you all for coming out. Are there any questions?
So you said if you were to be marketed, it would be around $600. How does that compare to a putter with the same technology that's on the market right now?
So like I talked about, putters don't really have a lot of technology. The putter that I had was pretty much this without a weight track, which doesn't have a whole lot in it. But Scotty Cameron sells their putters for about $450, which is kind of at the top end. So this would be a really high-end putter, definitely kind of at the top of that price range. Probably a few things that I would do differently is change the design of the weight track. I wasn't in love with the way that it looks, although I like the idea and performance of it. I would also like to do some quantitative testing with the system, like the